Well, hello, folks. You have Jim Prisby, and soon I'm going to introduce Mr. Rich Medairos. Can everyone hear me? Either on your screen, either raise your hand or let's see. I can see some hands. I see Keith and Kevin and Shannon. Awesome. I'm not sure where you folks are. I see T. Lowe. Is that Ted Lowe, the famous Ted Lowe? Or it might be someone else. But anyway, Jim Prisby. I'm the commercial sales manager for the Central Region, and you have signed up for the deep dive into Taco's HSS software, which is worth 1 PDH if you stick around. And before I introduce Rich, I'm going to give some quick information and we'll get started. So thank you for all those that have typed out some answers. That's one of the things I'm going to share. So on your screen, you should be able to see an area where you can type in some questions. That is ideal. I'm going to be monitoring the questions. Our good friend Brett Zerba is out today. He's getting a tooth pulled, and I think there was a vet in the office, and Rich has, I think, a nice set of players that could easily pull that tooth, but I think Brett decided to go to the dentist. So I'm filling in for Brett, and I'll do the best job I possibly can. So what I need from you folks, lots of questions. Rich loves questions, and I'll be monitoring the question section. And if there's something that we can, we'll have Rich pause and answer that question if at all possible. But a couple things that I want to point out. At the end of this, you will get a email roughly 24 hours after the presentation ends. You'll get a email on the recording, and then also a way to get your PDH if that's what you choose to do. Anyway, with that said, Taco Tuesday has been a long staple for Taco. I'm extremely pleased to be a part of the team. I've been on board just under 2 years, and I reside near Chicago. And if there's anyone in the Chicago marketplace, I cover the Central Region, which is 15 states. So somewhere in the Central Region, I might be available or work with the local rep that you might already know. So anyway, with that, without further ado, let me introduce Mr. Rich Medairos, our PE. Rich, can you hear me?
I can, Jim. Can you hear me okay?
I can, and I see people have said they can see your screen, and can everybody hear Rich? Just a show of hands. I see Mike, I see Ted still, and those might be hands up for questions. I'm not sure, but I'm going to ask. We'll type in the questions first. But thank you, folks. All right, Rich, go ahead, sir.
Thanks, Jim. A quick introduction for myself. My name is Rich Medairos. I'm one of the senior systems engineers here at Taco. And I am a mechanical engineer. I specialize in the engineering and design of HVAC systems. I am a PE, as Jim mentioned. I'm registered in several states in the United States. And I've been doing this for several years. I won't tell you how many because then I'll give away my age. But I will say that I am over 25. So if you want to guess my age toward the end of the of today's presentation, we'll give away a free prize, which would include a 6-inch Subway sandwich, just a sandwich, not the cold drink and the potato chips, just the 6-inch sandwich. We give that away if you get my age correct.
You know what? I might dip into the Central Region account and add some trimmings to that sandwich. But Rich,
like pickles and onions.
Are we talking closest by the day or the month? What do we talk? I mean, you're putting a substantial bounty on.
Yeah, no, I mean if you can get the month, the year, the exact year, and then or the exact age, and then within 6 months for the month. How about that?
Oh, wow. So this is not a jelly bean counting exercise, not to the nearest jelly bean.
No.
Okay, just checking.
Okay,
All
so you
right.
can see on my first picture on the screen here, Introduction to HSS Software. We've also been calling it a deep dive into HSS software. And so what are we going to talk about today? Well, we're going to talk a little bit about what is HSS software, and then we're going to show you how to download the free Takeo version. And I put that up here because I want people to recognize that the Takeo version is absolutely free, and it's called the Hydronic version. We'll talk about that a little bit more. Then we're going to use the software to do a basic manual hydronic system. We're going to design the system manually. And then we're going to show you how to utilize the wizard. And then we'll have questions at the end. But if you have a question, type your question in, as Jim said, and Jim will ask me to pause periodically so we can answer your questions in real time. So don't worry, you don't have to wait till the end. You can ask your questions at any time. Feel free to type them in. So right now, very quickly, while I show you how to download the software and then also tell you what is HSS software, I'm going to do both at the same time. It's kind of like juggling and talking at the same time. Okay, so let's go directly to Takeo's website. Oops, got some cartoon characters there. I'm going to click on Takeo Comfort Solution, and we are at the home page for Takeo's website. And if you'll notice, there's a tab right in the middle. It says Software, and then in the center of that drop-down menu, it says Best Building Efficiency System Tool, and then HSS, Hydronic System Solutions. So that's where that's what HSS stands for. So if I click on that, you can see the software is the second one from the left. You can see my cursor. Now, I'm not going to actually download it, but I just wanted to show you how to locate it on our website. If you click download, well, I'm going to click download. It just asks you a couple of quick questions, and then you click on download the software. And when you download the software, you're going to get this icon that's on the bottom of my screen here. It looks like a little green pump. Actually looks like a white pump with green surrounding. And then when you click on that icon, the software will open up, and hopefully it'll open up. Yep, there it is. First try. Look at that.
Look at
And
that.
isn't that fantastic? So what is HSS software? Well, it is a hydronic system solution software that allows you to design piping systems for HVAC hydronic systems. Now, there are actually two versions of the software. The one that you can download free from the Takeo website is called the Hydronic version. You can also purchase for an additional, for a fee. Remember, ours is free, so but you can purchase. If you click up here on the top of the screen under Help, and then you can go to HVAC Solution website. That's the company that actually developed the software. Excuse me, 1 second, Jim.
Absolutely. So I downloaded this software this morning, the free version, and went through that whole process. I have it on my personal computer and my office computer. I needed to kind of do a deep dive. So if you have a Defender or virus protection or something like that, it might ask you, do you want to turn it off? Obviously, do what makes sense for you.
So I'm showing you the software. We at Takeo did not develop the software. It was developed by a company out in Salt Lake City, Utah. And the name of their company is in the upper left-hand corner here. It's HVAC Solution. And if you want the professional version, you can download the professional version after paying a fee. I don't know exactly what they charge, but if you manipulate their website, you can find it. So I'm going to go back to our hydronic version. That's the one that's on the screen right now. So everything I'm showing you today is that you can do on the free version. We have tabs up here, which I'll talk about in a moment. If you're trying to do drain and waste, it's not part of the free version. It's part of the professional version. So the one that's free from us is the hydronic. Okay, so the software is organized similar to any Windows-based software. At the very top is the title, HVAC Solution, happens to be Project 1. And if you'll notice, you'll notice a lot of the same headings that you find in a typical Windows software, this file, edit, view, insert, shape, and so on. All of those are up there. And then there's a new tab to open up a new window. And then there's you can open up an existing, there's the save button, print, print preview, all of those ones that you're probably fairly familiar with in terms of most software packages. Then you get into the actual tabs that are unique to the the Hydronic System Solution software. And you can see we have the wizard, and we're going to skip over air handling, rooftop, space, airflow. Those are part of the professional version. They show them here, but you cannot access it. For example, if I click on airflow, and actually I need to go to summer cooling here. If I click on rooftop unit and then I go to click on one of these icons here, say direct drive, I'm going to put a rooftop unit. I'm just going to, and I get a message. You see it says this feature is not available in this version of HVAC solution, and it tells you to purchase it online and where to call and so on. But if you click on the Hydronics tab or the Hydronics 2 tab, all of these functions are part of the free version. So now if I go, for example, and I get a pump, let's try a pump here, and I go with a base mounted horizontal frame mounted end suction pump, I get a little picture. I'm going to zoom in so you can see what it looks like. And now if I want to connect piping to that, that's part of this version. Okay, so that kind of gives you a quick overview of the free version. So again, we're working with these two tabs, one that says Hydronic and Hydronic 2. And the very first thing we're going to do is develop a very, very basic hydronic system. The first thing you typically do for this software is it defaults to 8.5 by 11 sheet of paper. So that's, and this is in, let's see, landscape view. So this would be 8.5 by 11. If I want to change the paper, I can click on the printer, and I happen to have a plotter. So I would access my plotter. I have a design jet, and then click on properties, and then I can go to custom, and you can see that custom is size. There's all these different size paper that you can select, all these different dozens and dozens. So for today's discussion, I'm just going to pick architectural D, and it's going to change it to a larger size drawing. Click OK. My printer is not connected, so whoops, I clicked canceled at the last minute. Well, that was silly, wasn't it? So let me do that again. And I click on properties, then custom, and I'm going to custom paper and scroll down until I get to architectural D. There we go, architectural D. Then click OK, OK again, and then OK one last time. And then now it's going to change the paper size. But since there's no printer connected today, it just shows the paper size. You see how much larger it is than the 8.5 by 11. Okay. One other quick little thing to note, there's a grid here. This is not a snap to grid. It's just for your reference. So if you're drawing a pipe, for example, and you're starting over here, it doesn't snap to the grid, but I can put the pipe. Now, if I hold down my shift key, I'll get a straight piece of pipe. Let's see if I can do this. Well, it doesn't want to do that. So I'll tell you what. Let me show you the grid itself. You can see the grid, and up here there's an orange button. It shows you display grid. If I click on that, the grid goes away. I click on it again, the grid comes back. So let's get into it. Let's build a basic hydronic system. We're going to start with a cooling load. So I'm going to go up here, and it says hydronic cooling imposed load. I click the down arrow on that little icon. I'm going to click pick a terminal unit. In this case, I'm going to pick a fan coil. Now I get a little fan coil, and I'm going to zoom in so you can see what it looks like, and drop it on the screen. Just left click, it'll drop on the screen. Now, if I double click on that icon, it opens up a dialog box, and it defaults to the load. So I'm just going to arbitrarily put in a load here, and I'm going to make it 600,000 BTUs. click on apply and then OK. And if you'll notice, it says I've got a fan coil. Now, obviously, my fan coil is much larger than what you would typically see for a fan coil, but I'm just demonstrating how you put in the load. And if my system is made up of one fan coil, that would be simple enough, but I'm going to actually have several fan coils on my system. So I'm going to click on that and then right click and say copy and then paste. Now I have another one over here. I can move that any place I want. So let's put it over here. Now I've got two of them. Let's put a little more distance between them. Then since it remembers what I've recently copied, I can right click and then just paste again. I get another one. And you can see I can put multiple fan coils fairly quickly on the screen. And let's see, I kind of wanted 5. How many do I have? 1, 2, 3, 4, 5. Okay,
You
so
got
I
them
have
all.
5 fan coils. Go ahead, Jim.
I said you got them all.
I do.
Is there a way to keep them nice and neat there, Rich?
And there is. So I'm going to highlight all of them, and I can left click and drag a little box around them. When they get highlighted, you'll see they have these little green grips, those little green squares on them. And then I can go over here to the left, and you can see if I hover way over here to the left, it says align left. Now they're all aligned. And then I can also align top to bottom. Okay. And you see space evenly top to bottom. So now I have them all aligned and spaced evenly from top to bottom. And if you're an engineer like me, you like to have things that are nicely organized on a piece of paper. Isn't that cool? That's like the
That
coolest.
is phenomenal. I wish I knew about this software way earlier in my career. I'll say that.
It's really cool software. Once you get used to it, and as I said earlier, this is an introduction. So hopefully we can whet your taste and you'll get interested in it. And then you can call your local TACO rep and he can show you how to download the software, and he can give you some pointers on how to run the software. And then you can always call your rep, and they can always make arrangements to have someone from the factory, either myself or Brad or someone else, to teach you how to use the software. So you can also get classes on how to use the software at no charge. Okay.
Hey, Rich, quick
Yes.
question. You mentioned this was a Windows-based software, so can you use the same Control C and Control V for cutting and pasting?
I believe you can. So if we go Control V, yep.
There you
I did.
go.
I just pressed Control
Awesome.
V and it pasted it. Isn't that cool?
It is.
Okay, so now I have 5 fan coils, each one 600,000 BTUs, and I'm going to put in an air-cooled chiller, So if I hover over here, you'll see it says air-cooled chiller in the upper left-hand corner of the screen. And then I click on a down arrow, and I'm going to click an air-cooled chiller. No manufacturer for today, no manufacturer. And for today's discussion, I kind of like air-cooled chillers with screw compressors. So there's an air-cooled chiller. I'm going to put that over here on the right. And I'm going to zoom in for a moment so you can see. The air-cooled chiller has a supply water temperature of 44 degrees and a return water temperature of 54 degrees. So it's a 10-degree delta T. If I wanted to change that, again, I can just double click on that. The dialog box opens up for chiller air-cooled. You can see that CH-1 properties. And then for leaving water temperature, it has 44 degrees and has a little check mark next to it. But let's say I wanted to make it, instead of a 10-degree delta T, I wanted to make it a 12 degrees. So I'm going to change this to a -12 and then apply. So now I have 44 to 56, click OK. And now you can see I changed that. So I have a supply water of 44 and a return of 56. It's a 12-degree delta T. But it's not connected to anything. So let's connect it to our fan coil system with a piping system. Well, older versions of the HSS software required that I click on this little icon that has kind of a broken arrow, and that allowed me to connect pipes. So I zoom in here, and I want to put my arrow at the end of this piece of pipe, and then go over here. I'm going to double click for a moment. It's going to ask me if I want to terminate it at this point. I'm going to say yes. But the newer version, which is the one I have, is kind of cool because now I'm going to erase that pipe. Now, if I move my cursor close to the pipe, it changes to the piping connection symbol. See how cool that is? I didn't have to go up there and
I
get.
I wasn't aware of that. That's awesome.
Isn't that wild? Yeah,
I think it's
saves some time,
all about less clicks.
less clicks. So we're going to zoom out a little bit here. We're going to click on the pipe, and then this is the supply pipe. So I'm going to go over here. I'm going to supply the one at the top, the very top. There it is. And then I'm going to connect each of the other fan coils by just clicking on it, coming back to the pipe. And now I have a supply line connected to each of the fan coils. All right. And now I want to connect the return line. So I start over here with the return line. You can see that's 40. Oh, it says 54. And we wanted 56. So what we're going to do is highlight all of these fan coils and then look for their properties, property view here. And then I'm going to change from 10 degrees to 12 degrees. I'm going to put 12 in there. And the 44 to 56. Click on, and now I believe I've got the right values. Yes, 44 to 56. So now I'm going to make a connection for the return pipe. So again, I'm just going to hover over the return line, bring that return line out here, go up to the top of the screen, and I'm going to create some distance in a moment. You'll see why I'm doing this. And there we go. I'm going to move the chiller down a little bit, and
The
then
pipe
move
changed
this.
colors.
And the pipe changed color, yeah. As soon as you start putting a load together. So now I'm going to connect the other 5 fan coils. Again, it changes to the pipe connect symbol. And then I'm going to go from the out to the return pipe, make that connection for each of them. Okay. I'm going to, in a moment, in 1 second here, I didn't realize I was going to be interrupted. I'm going to shut off my email so we don't get interrupted by that again. Okay. So if you'll notice what happens, not only do I make the pipe connection, but each one of these is approximately, it's 600,000, which is roughly 50 tons of cooling. And then if you'll notice the chiller, if I zoom in here, the chiller is automatically sized for the proper load. In other words, I have 5 fan coils at 600,000 BTUs each. That comes out to 3 million BTUs per hour, and that comes out to 250 tons. And it's approximately 2 GPM per ton, which means it comes out to 500 GPM. And what's actually displayed here is 498.8. And the reason for that is that the software converts the flow into pounds per hour. You don't see it. It's done in the background in the calculation subroutines. And then it figures out what the flow should be, the mass rate of flow. And then it converts it back into gallons per minute. And that's adjustable based on the temperature. So the software does that automatically for you. But for all practical purposes, this is 2 GPM per ton, which is approximately 500 gallons per minute, 500 GPM.
So
Okay.
closer to 68 degrees, the closer it will be to the nominal GPM.
That's correct. Yep. Okay, so I've zoomed out. I know it's hard to see on your screen, but I wanted to show you just the kind of the general layout here. I've got the load on the left side. I've got the chiller sort of in the middle at the bottom, and I've got the interconnecting piping. But I need some way of moving that pipe, that fluid, or in this case, just straight water, around the system. So I need a pump. So I'm going to go up here, and the pumps happen to be green, which is always a good thing. They're the only pumps you can select with our free version software are the Takeo pumps. So if you go over here, and let's say today I'd like to use a vertical inline. So I'm going to click on vertical inline and get a picture for one. I'm going to zoom in so you can see what it looks like. I'm going to drop it. Before I drop it on the pipe, I'm going to hover over the pipe and watch the pipe's going to change here. Whoa, look at that. It has like a yellow. So it looks like it's going to be doing it correctly. So just for the fun of it, I'm just going to drop it on the screen without dropping it on the pipe. And when I drop it on the screen, if I go to move it on the pipe, you'll notice the pipe did not change color, which means that it won't automatically snap into the pipe. So a lot of people will do this, and this is, I know we're talking about basics today, but a lot of people will take and copy and paste a pump on their screen, and then they'll move the pump. Watch how I can do this. I'm going to trick everybody here. Move the pump and very carefully have it hover over the pipe. You can just barely see I'm hovering over the pipe. Now, when you zoom out, it looks like the pump belongs there, but it doesn't because it's not really connected. It was just moved there. So what I really have to do, if I want to use this pump, I have to copy it and then paste it. And now when I move this one that's ready to be pasted, the pipe will change color and it'll snap into place. Isn't that cool? So a lot of times somebody will take a pump. So I'll demonstrate here by creating a pipe. Let's say I'm going to run 2 pumps in parallel. And then I take this pump and I overlay this on top of the other one. And then someone will call me up and say, hey, I can't get the pump to calculate properly. Because you'll notice the pump in the top is 0 gallons per minute, 0 feet, and our pump is 498.8 gallons per minute, 24 feet. Well, that's because the pump's not actually connected to the piping system. So let's get rid of that pump and this piece of pipe so it doesn't get confusing. Now, what else do I need for a very, very basic system? Very basic. And I need to have an expansion tank. So I can go up here and I can click on vertical bladder full expansion tank. And again, the pipe's going to change yellow, so that means I know it's going to snap into place. And to make the drawing a little easier to see, I'm going to grab one of these green grips and make the pump a little bit bigger so you can see what it looks like. There we go. Move the pipe up a little bit. Oops. Sometimes it's a little finicky in terms of getting it lined up. Okay, so I've got a pump and an expansion tank. And the other thing that I need for an absolute minimum would be an air and dirt separator. So I'm going to go get an air and dirt separator. Let's see if I can, where is my air and dirt separator?
You had it there.
I thought I had it.
Right there.
Yes, there it is. Okay. So I want a high efficiency air and dirt separator. I'm going to drop that right on the piping system and it snaps into place. So I've got the 3 basic things. Well, actually, it's more basic than that. I've got the load. I've got the piece of equipment that generates the capacity. I've got a pump. I've got an expansion tank and an air and dirt separator. Now, if I double click on this pipe section, look what happens. It says the pipe length. It defaults to the pipe length. It says the pipe length is 0 feet. Well, I can't have the length of pipe 0 feet. So what I'm going to do is I'm going to highlight the entire drawing, and then I'm going to right click and go to properties, and then over here where it says pipe hydronic, it's also going to default to length of 0. So I'm going to put in arbitrarily, just arbitrarily put in 20 feet. Now I know that's not the actual length for every section of pipe, but I want some length in there. So I'm just going to arbitrarily put 20 feet in.
So everything that's highlighted is going to be 20 feet.
So every single piece of pipe now, if I double click on it, instead of 0 feet, it says 20 feet.
Nice.
Even the short connections over here, this also says 20 feet. Okay.
So does that impact the drawing automatically?
So now, if you'll notice, it has, instead, before it had, I think it had like 24 feet for the pressure drop. Now it has 36.9 feet at almost 500 gallons per minute.
Look at that expansion tank too.
Yeah, and the expansion tank went up. Because if I double click on the expansion tank, if you'll notice, it says component volume, 902.4 gallons. So that's a question that comes up all the time, especially when we're sizing expansion tanks. Someone says, well, how do I figure out what the volume of fluid is in my system? Well, if you use this HSS software, you can quickly find out what the volume of the fluid is in your system by simply putting in some pipe lengths, and it'll calculate it for you. Now, what about the pipe diameter? Well, again, I'm going to highlight the whole drawing. and right click, and then I'm going to go down to it says connect annotations, and then click on diameter. And now if I zoom in, you'll see that it has put in all of the pipe sizes. It's all the mains are 6 inches, and then the branch piping, you can see it starts off at 6, and that's after each takeoff, the pipe size goes down a little bit, and the smallest one is 3 inch.
Hey, Rich.
Yeah.
There's a couple questions, and we'll get to in a second, but what if 5 inches not in our arsenal of pipe fittings that we deal with?
Excellent question. So what we can do is we can highlight the whole system here, and then we can go to properties view, and then pipe hydronic, edit, and then where it says dimensions, no, let's see, I think yeah, there's construction. Let me make sure I get the right one. I have a feeling I went to the wrong place, Jim. All right, I think it's in the map. Let me try it this way. Properties view. Then we come down here to pipe hydronic.
Right call out, sir?
I think this is it. No, that's the call out. There's the pipe size. Okay, so these are all the pipe sizes that the software has available. If I don't want to use 5 inch, I can deselect 5 inch, click OK. And if you'll notice on the drawing, 5 inch disappeared. So now we either have 3 inch, 4 inch, or 6 inch. It's no longer using 5 inch. So I shut off the 5 inch pipe. Pretty cool, huh?
That is, again, I can't stress enough. I wish I knew about this software long before. I've been doing this for a few years too.
So do we have some questions out there?
We do, and I'm going to throw this out. I didn't want to stop you in the middle. So first one kind of was, you adjusted the chiller size, but what if you would have kept the coil temperatures on the air handlers, the 54? What would have happened?
Well, in this particular case, this is a primary pumping system, and so the delta T across the chiller has to equal the delta T across the terminal device in order for the system, in order for the software to calculate things properly.
Gotcha.
So if you put in a different delta T across the fan coil, the software is not going to fix it for you. You have to fix it yourself. Now, if you had a primary secondary loop, now you could have a change in temperature between the primary side and the secondary side. Yeah.
So I always understood this. If you know the fundamentals and you know beyond that, this is just making it a lot easier, and it's active, right? As you make a change, it automatically changes. I see the expansion tank, the gallons went up, the feet ahead. If we change the pipe size, the GPM might have, the feet ahead might have gone down by reducing or minimizing that 5 inch pipe to 6. No, that's fine. So there was another question. What would have happened if we changed the pipe length before we added the pump and the separator? I'm guessing you wouldn't have known until you added it because it's reacting to the feet of head.
Well, actually, we can show you what happens. Let's assume for a moment that I wanted to put in a valve. So I'm going to go over here to Hydronic 2, and then if you notice it says, if I hover over the valve symbol, it says control valve, Hydronic two-way control valve. But I don't want a control valve. I just want an isolation valve. So I can click over here. It's going to just say manual valve. I'm just going to get a, let's say a butterfly valve. And I'm going to drop that butterfly valve on the discharge side of the pump. And then I'm going to paste another one over here. Whoops. So I'm going to get another one and put it over here. Now watch what happens when I click on that section of pipe between those two valves. And you'll notice that it shows the length of 0 feet. So whenever you add a component, it doesn't know the length of pipe, so you have to put it in. So I try to make sure that when I'm doing a design manually that I put all the components in first and then I put the pipe length in. Because if I forget and I put a valve in, if you'll notice over here, length of pipe between the pump and the valve is 20 feet, but the distance between the two valves is 0 feet because I added those two valves, and then after the valve is 0 feet also. So if I wanted to correct that, I could just highlight those two sections of pipe and then go into Properties View, Pipe Hydronic, and then I could put in my 20 feet that I had from before, and now all the pipes, now if I double click on that piece of pipe, it's now says 20 feet. So you can certainly do it any way you want. You can put all the pipe sizes in before you put all your components in, but then it's kind of double work. You have to go back and adjust everything. But if you put all your components in and then decide what you want for pipe lengths, ultimately most people will customize the design layout and put in the as close to actual pipe length as they can estimate after they put all the components in the system. So it really depends on which way you're doing it. Does that help, Jim?
Yes, that I believe that answered the question. And then one other, why have you here? What if you change it from water to glycol?
You can do that, yes. So we can again can right click and go to Properties View, and then go down here to, let's see, oh no, I'm sorry, I did that wrong. I go over here to the source, which in this case is the chiller. If I double click on the chiller, and now I can put in here the, let's see, where is the fluid shown? Is it on the key data? So it's the good news and the bad news here. Let's see what we've got here, head loss callouts. The good news is that I know most of the controls, but not all of them. The good news is that Brett is the real expert, but because of his tooth today. Well, I'm going to have to, oh, here it is, under hydronic, there it is. So right now it's water. We could pick, for example, propylene glycol for chilled water, propylene glycol. Then it asks for the concentration. The default is 30%. I'm not going to change it, but I'll just show you where to find it. I could change that to 40%, for example, and then apply. And now everything in the system, would I like to add a glycol feeder? And let's say yes. I'm going to add a standard glycol feeder. So I probably would put that right here and then connect that to the system right there. But I'm going to leave it as water, so I'm just going to go back a couple of things, and it should be water now. Okay, hopefully that answered that question.
Yeah, and I think you're going to get to a couple other as you continue drawing. So go ahead, sir.
Okay, so now the next thing, if you'll notice, I'm going to zoom way in here. You can see that the pump under P1 has kind of little pink shading over the number P1. That means the pump has not been selected, So if I double click on that pump, one way of selecting the pump, I can select the components one at a time. So I'm going to double click on that and then go down here to selection. Where's my selection? There it is. And if you'll notice, it wants its automatic selection. So I'm going to click on select. It's going to make a recommendation. And the one at the top of the list is the one that will allow you to, it allows you to select. So it's going to be a KS5007. And if I click, let's click apply. As soon as I click apply, if you notice in the drawing, the pink went away. And now the number is, that means the pump has been selected. So I'm going to go back here. I'm going to go to the undo, and now the pink is back. It's not selected. So that's one way I can select it. The other way is that I can go up here, and it looks like a thumbs up. It says select equipment. If I click on that, all of the equipment that is TACO based, actually there's other manufacturers in here, make a recommendation. If I click on that, it'll automatically select. Now if I double click on the pump, you can see it has a different selection this time. It's a KS6011. The KS5007 is also in there. but the KS6011, the automatic selection, is slightly more energy efficient. So you can make the selection one at a time, or you can make them all. So in that case, it also selected the expansion tank. So if I go under here, selection criteria, it has selected the expansion tank. It's also selected the air and dirt separator. You can see that right there. So I can either select the equipment one at a time, or I can use this little thumbs up, and it will select all of the equipment that has some manufacturer. In most cases, it'll select all of the Taco equipment, and most cases will select a chiller if you had specified who the manufacturer is. Now, not every piece of equipment has a manufacturer associated with it. Only the Taco equipment has all of our equipment covered in the selection, if that makes any sense.
Hey, Rich, quick question that somebody threw out there. Can you view the pump curve of the selection?
Yes, you can. So you can double click on the pump, and you can look under the main heading of selection. And if you go down here where it says performance, here's where the pump curve is. Now, before I do that, let's go back here to selection again. And if you'll notice, it says that it's a, if I can, yeah, I can double click on that. If I go down here to performance, what am I really looking for? Let's see if it is. Yes, for this particular pump, it's a 9.731 inch diameter impeller. So this is the curve for the pump. It's roughly 500 gallons per minute. I believe it's 500. Oh, nope, the gallonage went up a little bit. It did that because I believe we changed the glycol. So let me go back here and change this back to water again. Yep, I want to put that back to water. Yep, that's why the pump changed. Okay,
Right,
so now we have 500 gallons per minute, and we need a roughly, I believe, somewhere around 36, yeah, around 35 feet. So you can see that it would be in this range here, 500 gallons per minute and about 35 feet.
So it gives you a representation of where it's at. It doesn't show BEP and all that, but it gives you a really close of what's going on.
Right.
Perfect.
So in this case, it's a 6.803 inch. In other words, I made the selection. Let me go back here, undo. That's before it's selected. And now if I go to the thumbs up, it makes the actual selection. Now if I double click on the pump and go to the performance, I can see that at 500 gallons per minute, it's around 35 feet. So that would be an impeller diameter 6.803 inches. I can also look at the power curve, efficiency, and the NPSH.
That's good. We got about 11:43 Chicago time, so we're going to get through some other stuff. But another question, real quick, is building height. How does that come into play?
Well, that affects the expansion tank. So if you go in here, double click on the expansion tank and go to key data, if you'll notice it says the static head above the tank is 20 feet. That would be how you would adjust for the height of the building. So in other words, you would change this value as a function of the height of the building. So you would have to know the height of the building and then convert that into, well, if you have the height in feet. If it was in meters, you'd have to convert it back. And then you put it in here and then it adjusts for the expansion tank. Okay. Now I'm just going to show you quickly. Let's assume for a moment that in this case, we have 5 fan coils. Let's say at the last minute, someone decided, oh, wait a minute, we actually need to have double that. So I'm going to put 10 fan coils in here so I can copy that part of the drawing, paste it, and then simply make the connection between the supply side, which is here, make the connection here to here, and then the return side from here to here. Oops, I'll go up to here. There it is. And so now I've doubled. So instead of 250 tons, you can see that I have 500 tons, and it has resized all of the piping in the system. So I'm going to go over here and then go back to properties view, hydronic pipe, edit, and make sure I put in, again, I'm arbitrarily putting in 20 feet for every section of pipe. Click OK. Now I can display the pipe sizes. And now you can see that it automatically, let's zoom in this time, automatically changed every pipe size on the diagram. So I added, so you can think of it this way, sort of added another floor to the building, and it automatically recalculates everything. Now the pump still needs to be selected because it's a new set of criteria. So I'm going to use the thumbs up, and then it's selected the pump. If I double click on the pump and I go back to selection, you can see it's a different size pump. Pretty cool, huh? Any questions about how to do a manual system?
No, there's a couple of questions on here that I think you're going to get to. Based on time, I'm not sure. You're going to show how to, if these were zones, I'm assuming, showing the pipe, the most hydraulically distant piece of pipe. We're going to talk about some of that, I think.
Yep, I can show you that in a second. So today, let me just put today's date in. That's 8. Whoops. Yep, 8/3. Wow, it's August. Can't believe it's August already.
It is.
There it is. For some reason, I messed up, but that's okay. All right. So, so what did you just say, Jim? I'm sorry. I was trying to save this so that we could.
I think you're going to show zones so we can see what where the most hydraulically distanced pipe, the pipe with the most friction loss is going to be shown, I think.
Yeah, so that's very simple. You double click on the pump, and if you'll notice, if you go very to the top here, it says key data. See, it says show head loss path. I'm going to click on that. Now it's going to show you how that calculation pressure drop was done. It has done the pressure drop calculation for each branch circuit and the software decided that this that's highlighted in blue is the greatest pressure drop path right here. Isn't that clever the way it does that?
It is. So this kind of ties into another question. So can you put a balancing valve on each of those air handlers, and you can depict that, but that right there is the path of the most head. And if you
That's
put
correct.
balancing valves on each, then in the field somebody can make the adjustment. The software is not going to be able to do that, right?
Right, because the software assumes the balancing valve is 100% open. It does not have balancing capabilities. However, if you'll notice, if I zoom in here, this is imposed cooling load number 9. That's where it said the highest pressure drop was. So I can just arbitrarily come over here and change the length of this pipe. We know the length of this pipe is 20 feet. I'm going to just arbitrarily make the length of that pipe 100 feet. I'm exaggerating for purposes of demonstration.
You can't do that, can you?
I can if I want to. Now that pipe length, if I double click on it, is 100 feet. Now watch what happens when I double click on the pump, make sure my pump is selected. Now if I double click on the pump and then go to show head loss path, look, it has changed the calculation. Instead of the imposed cooling load number 9, it's now figured out that the pressure drop for the greatest run of pipe is this one up here, where I changed that section of pipe to 100 feet. So you can see how quickly it reacts to changes in the system that you make. It automatically does the calculation for you. And it does it very quickly.
Dynamic. Awesome.
Okay. So now I am going to erase the screen, and I'm going to now show you how to use the wizard. And in the wizard, I'm going to answer the questions rather rapidly. I'm not going to take time to explain every question I'm going to answer. And the purpose is I want to show you how to build a similar system to what we just built. Only now this time I'm going to go over here to the wizard, and I'm going to hover over the system wizard right here. It says open wizard file. I don't have one, so I'm just going to click on next. I'm just going to do a direct return system, cooling only. Click those two buttons, then go to next. Number of loops. Let's say I'm going to try to do similar to what I did a moment ago. Let's say I want them to be vertical. Click on next. Number of loads in each loop. We said 5 from before. And I'm going to make the orientation left just for the fun of it. There will be fan coils. Each fan coil will have a two-way control valve. I'm going to make the fan coil load roughly the same as I did before, which I think I made it 600,000 BTUs. So I'm going to put in here 480,000, and hopefully, if I do my arithmetic properly, yep, it comes out to 600,000 BTUs. Enter that. I want an air-cooled chiller. Next, I want one air-cooled chiller. I want, hold on while I hang up that other phone. I apologize.
No problem. So there's a couple, I think we're trying to get some of the questions all answered. If I have Rich show them, otherwise I'm trying to answer them behind the scenes as well. So keep them coming. Thank you.
Okay, so we're gonna make this a manifolded system, and we're gonna have one pump like we had before, one expansion tank, high efficiency air and dirt, finish. And now I have very similar system to what I had before. I don't have any pipe lengths, so if I double click on a pipe length that still says 0, I'm just going to arbitrarily highlight everything and then go to property view, pipe hydronic, edit, and then put in 20 feet for every section of pipe, just like I did before. Click OK, and then click the thumbs up. And you can see by using the wizard, I have created a system very similar to what I had before that I did manually, only I did it in a fraction of the time. Pretty cool.
That was that's a pretty rough. That's a great idea to be able to share with someone different concepts.
Yeah, exactly. And this time the software, the wizard, has put in the control valve because we specified a two-way control valve. It's also putting the balancing valve, and it put some isolation balancing valves scattered throughout. It hasn't displayed the pipe size, so I can go over here and I can double on connection annotations, diameter. And again, it shows all the pipe sizes. So I can zoom in for a moment and you can see the different pipe sizes. So you can build a system manually. It's kind of like if you've ever been involved with home construction, there's two terms they use. One's called on-site building. Sometimes it's called stick building. And it got its name stick building because if you were building a house on site, I'm talking about a single family home. I did some house construction when I was younger. And you know, you'd order the lumber from the lumber yard and they literally delivered the lumber at your site, and it would all be in sticks, just separate pieces of lumber. Or you could get it prefabricated. So our software works the same way. If you're doing it manually, it's kind of like stick building, one piece at a time. You put the pipe in, you put the pieces in, you connect it all up. Or you can use the prefabricated option, which in this case they call it the wizard, and then you can fabricate the whole thing in a fraction of the time. And it gives you a starting point for your hydronic system. And you can be as sophisticated as you want to be. I did a very simple system so I could show you the basic version manual and the basic hydronic wizard to show you how quickly you could do the same system and do it using the wizard. Okay, so we have a few minutes left. Jim, any questions out there?
Yeah, a couple. So one of the questions was, can you do primary, secondary piping and all that stuff? And the answer is yes. You can visually do it. You could add you could put multiple pumps in parallel, and maybe, you know, just by adding the other pump and connecting the piping, even to this drawing, right? You could actually add to that drawing after you.
Yeah, actually, see, I've
Set it
got the
automatically.
drawing the way we had originally envisioned it. I can go back to the wizard and just go through, and this time, instead of having, I'm just clicking next, 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 and then when I get to the number of pumps, let's see if I got here. I could put in 2 air-cooled chillers, for example, instead of 1.
Yeah, redundancy. Yeah.
And then I could put in, let me go back to where it asked for the pumps, 2-way control valves. Oh, I know. Because the pumps themselves want to be, let's say I did a primary, secondary, and it's going to ask me how many secondary pumps I want. Let's say I put in 2. And I've answered all the questions. And now you can see I basically have a very,
Nice.
very similar system, but instead of 1 chiller, I've got 2 chillers, redundant chillers. And instead of 1 pump, I've got 2 pumps in parallel, and I've got a primary, secondary loop.
Yeah. Nice.
So all I did was I started with a basic system, and I did the same thing that you did, Jim. I just said, well, what if I wanted to make some changes? I don't have to go through. All I have to do is change a couple of parameters, and bingo, I've got another system design.
Okay. Two more questions. We're ticking down on time. So here's one. Does the expansion tank selection sizing affect the system pressure, and does it indicate that? Because we didn't talk about.
Yes, you have to decide. So I'm going to double click on the expansion tank. If you'll notice, it has the relief valve pressure.
Yep, 30
It
psi.
also has the minimum fill pressure, the maximum working pressure, the minimum tank volume, and maximum acceptance volume. So you have to decide what you want for minimum and maximum pressures, and you want the relief valve setting. So you change those manually, and that will customize the expansion tank.
Okay. And then the other one, can you click on the drawing you just did and show how the critical path of the pressure drop again?
Yes, so you click on the pump, that's the first step. In this case, I'm going to click on the secondary pump. Let me zoom in a moment. The primary pump is associated with the equipment. This is the primary pump, P4, and here's the bridge over here on the left. So this is the secondary circuit. So if I zoom out, if I double click on the pump, the secondary circuit, and then I say show head loss path, you can see it has calculated the greatest pressure drop based on the blue line has outlined where that calculation is being done. See how that's handled?
Yeah,
Pretty
yes,
fast.
that's perfect. And if you would have changed the longer pipe, it would change the critical path. So awesome. Thank you, Rich. I think we addressed all other questions, but there was someone that's had his hand up for quite a while, and I'm guessing he forgot. It's been 69 minutes. So Jerry, I think you were sharing that you can hear us. I'm going to take that as that. And I think we had Rich. Great. I think we got all the questions answered, and we have 2 minutes to spare.
So do we have any other questions out there that people were dying to ask?
I'm
going to show you in less than 2 minutes. I'm going to save this.
Okay.
I'm going to save this also here as project 2.
There was all birthday related, guessing your age.
Yeah, that's right. Did anybody come up with my age within the year and the and you can't, Jim, you can't say because you'd be cheating.
I'm going to say there's some people, there's someone that might be close, but I'm not counting the jelly beans.
Okay. So while they're thinking about that, and we have 1 minute left, I'm going to show you how to design a chiller plant in less than 1 minute.
You're on.
I'm on.
For a Subway sandwich?
Yeah, why not? So we're going to do a cooling only, and we're going to do a water-cooled chiller with the cooling tower. And I want, let's say, 4 chillers at 25% each. And then I want 4 cooling towers at 25% each. And I want a primary secondary system and a manifolded system And for secondary pumps, I want 3 pumps at 50% each. And I also want 3 pumps here at 50% each. And I'm just going to click through the rest of these, and lo and behold, through the magic of the software, I now have a chiller plant. I don't have a load yet. So to get a load, I would come up here to Hydronic, and I would pick a building. In this case, I would like to make it an office building. And then I'm just going to connect the pipe to the building. And then on the discharge side, connect it to my chiller plant. Now I'm going to put a load in for the building, just arbitrary load. I'm going to make it 10 million BTUs. And if you'll notice, it has sized all the chillers, all the pumps, everything in the system almost instantaneously.
I didn't have the second hand going, but I think that's pretty darn close to a minute. I'm plus or minus 30 seconds, maybe.
Yeah. Pretty cool stuff. And if you notice, I have a fairly large building, so my pipe size is 12-inch. Okay. That's pretty much everything that I wanted to cover today, and hopefully we've answered your questions. So I have my little minion here that says thank you. And any last minute questions, Jim, that we might be able to answer? If not, I'll turn it over to you. Jim, did I lose you? I lost Jim.
Nope. We got too many screens going on. So you know what? Just some good comments. I think the age thing will have to be taken offline. I see the dates. You know what? I'd have to guess myself, folks. I'm thinking 47, but I don't know. Maybe August. I don't know. But,
I'm 47 years old, and I was born in August. Is that
well, I can't win.
You can't know because you're cheat. You already know, Jim.
All right. Okay. If I have a premise that not yet been defined, blah blah blah, can I plan pipe for shut off? You know what? We'll have to get back to one of those questions. But offline, we'll send some. We'll take a look at any of the questions, and if we weren't able to answer them, we can get back to you. Anyway, folks. Jim Prisby, Central Region Commercial Sales Manager. I'm going to turn it over to Rich for the parting words.
Thanks, Jim, and thanks everyone for participating in today's discussion. As I said earlier, this is an introduction or a deep dive, another way of thinking about it. And if you want to learn more about the software, contact your manufacturer's rep, and they can set up training if they like. You can get training either through the manufacturer's rep. One of the folks on their team is very versed in the software. And if you want to set up a training for you and your company, you can make that request through your rep, and they'll contact us here at the factory and be happy to do that for you. So thank you so much. And at this point, I'm going to say goodbye, and hopefully we'll see you again on the next Takeo Tuesday. Take care, folks.